we are going to look at elastic load balancers, and we will also proceed to set up a classic load balancer in the lab class. I will explain you why we need a load balancer and what are the different types of load balancers available and what configurations are possible in each of the load balancers. And we'll go ahead and proceed to set up a classic load balancer. We will also look at Route 53 introduction, and we will look at the demo for Route 53 in the following class. So typically we are in the networking group of services that Amazon offers. We already looked at how VPC helps to customize your IP range and protect it using security groups, using routing tables, and also using network ACLs. So continuing on the networking group of services, we are looking at ELBs today, Elastic Load Balancer. Before we start looking at the Amazon Elastic Load Balancer, let us look at generally what is available with what happens without a load balancer. You have an end user or a customer who tries to reach your instance. Most often what you do is you give the IP address of the server, or you share the domain name of the web service that is running on the instance. But what if you are running multiple instances? Then you are forced to share all your IP addresses and also your domain names for multiple servers. So if you are using such a scenario, then it becomes very difficult to scale your applications to huge number of servers. You cannot keep on changing the front-end username or a host name. Think of Flipkart changing their URL every day. You have multiple instances, multiple services running on the background, and for each service you need to use a different URL. That becomes very difficult. That is when what people usually do is they introduce a load balancer in the front so that your domain name is common for everybody and the load behind the servers are shared between multiple EC2 instances, or it can even be an S3 bucket also, depending upon what you're sharing with your end users. It can be anything. What is the origin, in other words, here we can use. So the load balancer takes care of distributing the traffic, and also it takes care of health checking your instances. It also takes care of making sure your instances are utilized in a proper way and initiate recovery actions whenever an instance is not in a healthy state. For example, the elastic load balancer here is, or what it says is, it automatically distributes the incoming traffic between multiple applications or microservices. It can be containers, it can also be EC2 instances, it can be anything. And Amazon says it is elastic. What it means is, as the load increases, your load balancer also scales up appropriately. It runs on a bigger instance and it can distribute the traffic across all your instances uniformly. So you don't have to worry about the capacity or capabilities of your load balancer. The load balancer is fully managed by Amazon, and they take care of the hardware and software part of it. You just have to create a load balancer service and associate it with your instances. So the second part is, it is Amazon is saying the load balancers are secure, because we need to secure this, as this is the front end for your website. This is going to be where all your attacks are going to come in. This is through this service only everybody is going to access your private servers or public servers. So you need to secure it. And how do you do that? Load balancers can be put in their own security group, and load balancers will also reside within your VPC. So using these two controls, you can decide who is going to access your load balancer and what ports are going to be open, what IP addresses are going to be open. And Amazon also says that it is integrated, meaning it works very nicely with S3 buckets, it works with EC2 instances, it also works with containers or microservices. And the last part, it differs how you look at it. A load balancer is always having an additional cost associated with it. It is not a free service. So even if you are having a free tier account, you will be charged for certain amount of hours that you are running the load balancer. And load balancer charges are something like there is a rental charges, that is if you're running it for X number of hours, you will get some charges, and there are also transfer charges. How much of GB data is being transferred in and out of the load balancer. So depending upon your region, these two prices will vary. And also your intra-region transfer is also there, and inter-region, that is within your VPC or within your Mumbai region, how much data you are transferring within the load balancer. And when talking about load balancer, I should also add this point. There are two types of load balancer, we can say. One is internal load balancer, that is not external world facing, that is your applications will have a load balancer within the VPC and external world doesn't see that. And there is an external load balancer, that is internet facing, as Amazon calls it, meaning this is through your internet traffic comes in. A proper example is typically Flipkart or Amazon website will have a load balancer in front of it. Whereas for an internal load balancer, think of accessing your HR application in your office. You want to do something in your payroll or tax deductions or submitting tax proof, those servers will be sitting behind an internal load balancer. You will not be receiving external traffic through that load balancer. There are companies which will allow you to do that. Let us look at a very smaller company, not an enterprise like Accenture or something like that, where all your internal servers are accessible only from your corporate VPC. Moving forward, this is a rough architecture of how an elastic load balancer looks like in a real world scenario. Consider a small VPC that you have in the US West region, and you also have instances on two availability zones, 1A and 1B for high availability. So you need to distribute traffic to both these group of instances equally so that one instance does not get overloaded. So that is when what you do is you introduce an elastic load balancer in a separate VPC or in the same VPC. You can do it either way. There is no hard and fast rule to put your elastic load balancer in the same VPC. But remember that when you are doing a different VPC, you will have to pair them so that they can talk to each other. So assuming you put the ELB in a separate VPC and you need to give two subnets minimum for the VPC to work, because load balancer needs to be highly available. So whether you are using multiple subnets, multiple availability zones or not, you need to give minimum of two subnets for your load balancer to work. So here we have made it equally parallel. So US West region will have one load balancer. I mean, I am not going to say one load balancer because Amazon takes care of the instances. You are going to create only one instance, and Amazon will have two on the back end. It will take two IPs, one from one A region and one from one B region. But if you go to your dashboard, you will see only one load balancer running there. The instance will be shown as only one. But in actual reality, there will be a traffic routed to a separate load balancer in each of those regions. And Amazon automatically maps the traffic appropriately. So 1A talks to the instance in 1A ELB, and 1B talks to the ELB in 1B. So this is how internally the traffic is routed. You don't have to do anything. You just have to choose your VPC. You just have to choose your subnets. And then of course, if you have Route 53 configured, then you can create a CNAME, or in other words, alias for your ELB domain name. ELB creates its own public routable domain name, which is alphanumeric.amazon.com. So if you don't want to use that, then you create a CNAME in your Route 53 record sets. So this is just a very high level feature set of Amazon ELB. You can have support for both public and private VPCs, public and private IP addresses. you can load balance over EC2 instances within a VPC. That is, as I told you, you can have containers also. That is relatively coming up new technology. They launched something called application load balancer, which is very relevant to containerized applications only. If I want to deviate from the main topic of ELB, a little bit talk about containers. Containers are started and destroyed more than EC2 instances. Let us say you can start 10 containers in the same time that you can start a single EC2 instance. That is how fast or how quick you can start a container and destroy a container. You can ask me what is the benefit of doing all that. It is for rapid prototyping, rapid testing. I want to see one feature, how it looks like in a particular application. So without disturbing my existing application, I will deploy it in a container and check the feature is working or not. And I will destroy the container quickly. And what happens is, for each container, I need to connect to that application. So I will have a different port associated with it. In other words, port association will be dynamic in containers. It will not be standard like port 80 for web server or port 3306 for MySQL, I'm sorry. So port location is dynamic in containers. If your ports are dynamically changing, then your ELB should also be capable of routing traffic to the dynamically changing ports. So that is why Amazon came and introduced something called application load balancers, which is directly aimed at load balancing containerized applications. And it can also route traffic based on rules. We will look at that in a short while. So as I was saying, Amazon ELB allows you to health check your instances. What it means is it constantly checks for a particular URL or a path that you give ELB, and then that path will be constantly checked. Say for example, www.google.com, it will constantly keep on checking and see if it is not able to reach www.google.com on a particular IP or an instance, it will say that instance is impaired or failed. I'm sorry about that. It will say that particular instance is impaired or failed, and it will stop sending traffic to those failed instances, so that your customers are not experiencing any difficulty. If I want to show the same scenario in a more pictorial way, this is how it looks like. You have 3 instances and all of them having uniform load as of now. That means that all instances are working fine and the load balancer is also working fine. So all of a sudden what happens is your first instance is increasing load. That means its CPU is going high or memory is going high. In other words, it is not performing very well. It is having some issues. So the load balancer will notice this and it will stop sending traffic to that instance. So automatically what happens is that traffic has to be rerouted to other instances. So you can see the load increasing on the other 2 instances proportionally. So either you will go and investigate the first instance, or you will have an auto scaling group which will automatically replace that instance into another healthy instance. So you can, this is how auto scaling and ELB works together. Auto scaling will send that information to CloudWatch, and CloudWatch will send that information saying, I have a failed instance. Auto scaling, be aware of this, start a good instance for me and throw away the bad instance. So I have replaced a bad instance with a healthy instance now. So automatically auto scaling will register it with ELB, and ELB will check that and start routing traffic to it. And once I start routing traffic, automatically the load on the other 2 servers will also come down. This is how a real world scenario will happen in load balancer applications. I have just simplified a lot of things here, but if you can imagine, if you want to visualize how the load balancer works, this is how typically that would happen in a load balancerized applications. So talking a little bit more about health checks, again coming back to the same topic because this is important and you need to understand what are the features that you get for health checks. If somebody asks you to configure multiple health checks, you have to tell them that you can do a HTTP check or a HTTPS check, or you can do even a simple ping test during using the port TCP. I'm sorry, using the protocol TCP. And also you can determine how often you want to check the server. If you start polling your server too often, that means that you're increasing your administrative traffic rather than the customer traffic. So you need to be careful in choosing the frequency of your servers, frequency of your health checks. It might not be a bigger problem when you have 2 instances, 3 instances, or 5 instances. But if you have like hundreds, you will not put more than like 50, 20 or 30 or 50 in one load balancer. You will probably distribute the load balancer itself to different regions and different availability zones. So even if you have 50 and you have multiple health checks configured and your frequency is also higher, your administrative traffic will be more and your load balancer will be performing unproductive tasks most of the time. So the last point is significant in that matter. Consider the depth and accuracy of your health checks. So just don't check for something which is easy to do, something like a root HTTP uh, domain name slash index.html. That is a very easy thing to check. Just checking for your home page. Or you want to check whether your shopping cart is able to do a checkout page, whether you're able to reach out to the checkout page, or you want to configure it, say particular product page, you're able to see it, or you want to be able to see a particular video and streaming starts after you load that video. So you can have any kind of a depth and accuracy configured when you're doing your health checks. For that you need to understand the application architecture. Mostly this information will come from your application teams or development teams. They will tell you if I am getting a request, this request is successful, that means that my application is working. So they'll probably give you an URL and they will ask you to configure health checks for that URL. And this is another important item that you need to remember. When I say important, this if you are not doing your ideal timeouts correctly, your load balancer will have lot of active connections. Imagine a scenario, you have 3 web servers and each of those web servers can handle 10,000 requests at any point of time. So your users are totally about 40,000 at this point. That means that all 3,000, each of those servers are doing 10,000 and you have 40,000 requests waiting. So the load balancer would have sent 10,000 to each of them and still another 10,000 users are waiting to get connected to your servers. So what the load balancer needs to do is it needs to find out which connections are idle and start terminating them so that new users can be connected to the servers. So how do you identify which connections are idle and how much time you want to wait for them to be marked as idle? That is where this idle timeout is coming into picture. It will find out connections which can be closed by the load balancer which are no longer in use. That is, there is no keep alive traffic or there is no traffic, but the session was created some time back and the user is no longer using that session. For example, think of opening a web page and you just moved on to some other web page or you moved away from your desk and started doing some other activity. For you, there is a session created with the server and there is a load balancer connection made for you specifically. And load balancer finds that in the last 5 minutes you have not transacted anything on the page and you have not made any request. Then load balancer closes your connection. So if you come back after 10 minutes after the load balancer clicks a connection, you will have to be logged in again. You will be forced to log in again. That is where this idle timeouts come into picture. So the text here says the same thing that I told you in a lot of words. That the length of time that an idle connection should be kept open and how often you want to disconnect it. You want to wait for 60 seconds or you want to wait for 360 seconds. 3600 seconds, that is 1 hour. So you configure based on your application. If anybody in India will know that IRCTC logs you out in about 5 minutes of idle time. This is how things like that are configured. If you are idle for about 5 minutes, your session will be disconnected and you will be forced to log in again to recreate a session. That way more users can use your application without you spending more money to scale up your application. And this I reiterated in the beginning of the architecture only. Always use multiple availability zones for high availability. So you will be protected from AZ failures, that is zone failures. Amazon talks about 3 levels of availability, that is instance availability, zone availability, and then region availability. So use multiple instances, use multiple zones, if possible replicate across regions. That is how you achieve high availability for your applications. When you are doing architecture, you should always remember these 3 concepts: instance, zones, and regions. And this is another thing. In each of those, what sometimes people do is they will take only one availability zone and create 2 subnets within the same availability zone and put that load balancer on top of that. That will also work as a requirements points of view. But are you achieving resiliency? I don't think so, because if the availability zone is gone, you will still not be able to access your application. So that is why you create 2 subnets in different availability zones. Always remember that you need 2 subnets to make your ELB work, and those subnets is preferably should be on different availability zones. Don't ever create it on the same availability zone and say that you have created a resilient architecture. It will work, but it is not resilient. So this is this architecture you should be familiar. We just now saw it. I just wanted to show what happens when your AZ goes offline. You have an AZ level failure. What happens to your load balancer? So typically you have your right hand side, you have your customer VPC running 2 instances of the same application, and your load balancer is configured and Route 53 is also configured. So if I move forward, let us say US West B, that is 1B availability zone is having some issues, this one. If we move forward, what happens is all the traffic from here will also be routed to 1A. Of course, this will impact the performance of 1A server. It will have a very high performance metrics going all over the place, but still your customers will have some amount of access to your application instead of no access when they were in the 1A failure, 1B failure. So this way you are reducing the impact of the downtime that you are experiencing because of 1B unavailable, but you are not completely removing it. So the idea here is to have somehow level of availability for your customers and fault tolerance built into your architecture. So there is one more scenario. What happens here? People do this kind of architecture also sometimes. What they do is in one region they create a very big instance and they call it like, for example, I have an 10 CPU, 16 GB RAM instance on one availability zone, and in another availability zone they think that okay, it is load balanced, so let me start a cheaper instance here, multiple cheaper instances. So what happens is your load is not equally distributed. As you can see, the bigger instance, of course Amazon knows that you have a bigger instance configured and it tries to send more data to that instance. So if you have a one-to-one mapping, that is availability zone traffic has to go straight away, this happens. To avoid this, there is a concept called cross-zone load balancing. What it means is you will be sending traffic crisscross way. It is just a checkbox in your configuration console which will say enable cross-zone load balancing. If you don't do that, you will have a scenario like this, and when you enable this cross-zone load balancing, what happens is your traffic is rebalanced across all your instances. So this way, even if you have a higher instance or bigger performing instance on one availability zone and multiple smaller instances on another one, you can still load balance them appropriately. So this is just an architectural logic that I'm explaining here. This is nothing to do with configuring a load balancer. So these are all different scenarios that you will be asked when you're trying to configure a load balancer. When a customer or your service manager comes and asks you, can we have a one big instance only in one place, another multiple small instances, so that I can stop the smaller instances whenever I don't need them? Then you can tell them, yes, you can do that, but also you need to do cross-zone load balancing, so your load balancer manages the traffic appropriately. So this is some more text which explains that there is no additional charges for doing cross-zone traffic. So go ahead and enable it if you are going to have an imbalanced instances in two ACs. And DNS caching is something, if you are familiar with applications, what happens is the DNS caches frequently requested domain names and also URLs. So it tries to send traffic to the same URL or a domain name whenever it gets a request. That is, if you know DNS, it is a domain name to IP address mapping. So it is, if it is mapping to an old instance which is already underperforming, then DNS will not know that. It will keep on sending traffic to the same IP address. But once the traffic reaches your load balancer, what I'm saying is here, the DNS, this Route 53 that has, this guy will keep on referring to this underperforming bigger instance. So once it comes from there, it comes to load balancer here. One second, guys. So what I'm saying is, DNS caching will send the request to the same IP address to load balancer, but load balancer will know that this instance is underperforming. I should not be sending traffic to this guy anymore, and will start sending traffic to this guy. So cross-zone load balancing will absorb the impact of DNS caching and eliminates imbalances. So those kind of scenarios are also avoided when you are doing a cross-zone load balancing. There are a couple of flow charts, graphical charts are there, but I did not include them because it doesn't add much value there. So there are two more topics that we want to understand before we go ahead to the demo. One of them is listeners, another one is target groups. What are listeners? Now I'm just going to go back to the previous slide. See, here I have an ELB and here I have an EC2 instance. These two are mapped. But for what incoming request I should be listening to, what port I should be listening to from the external world, that is what listeners are coming into picture. So listeners are nothing but the protocol and port that the load balancer listens for incoming connections. And you can have multiple listeners configured for each of your load balancers, and it goes up to a limit of 10 listeners. And you can also have routing rules configured. What it means is, if you have www.amazon.com/ okay, let me take a Google example here, google.com/YouTube, you will be redirected to a particular group of servers. google.com/gmail, you will be redirected to a particular group of servers. So you can have routing rules also on your listeners based on your path, that is the URL that you are given. So that is where the listeners are coming in, and you will be configuring listeners of your applications. So rules, we were just now talking about it. It is a link between your listeners and target groups. That is a new word again. What is a target group? The target group is nothing but the destination where your traffic is sent. It can be your EC2, it can be your container applications, it can be your S3 bucket, it can be anything where your data or application is coming from. So a rule is nothing but like Gmail is there after the domain name. Okay, I have found out Gmail is there. Then this is the group of target. This is the Gmail target group I need to send the traffic to. So if there is a YouTube in the URL, then this is the traffic group of servers I need to send the traffic to. That is how rules work. Today you can send forward request to a specified group, and there are multiple combinations is possible. You can even use regular expression when you are configuring your rules. in your load balancer. It is pretty advanced. If you are, you will have to work with your application team to configure rules so that the traffic is redistributed appropriately. For example, if you take an example of IRCTC again, after you finish your booking your seat or identifying which train and seat and the class that you want to choose, you will be redirected to a payments page. Once to the payment page, you will be redirected to a complete URL called a payment gateway. So how does it happen is you will have a URL saying www.irctc.com/payment-gateway/ICICI. So once this rule is picked up by the load balancer, automatically it will redirect you to a particular server which is either inside your VPC or outside your VPC. And I'm taking IRCTC as an example here. I'm not sure whether IRCTC runs on AWS or not, but that is how typically you will configure an application for using rules. Target groups. Again, this is the end destination where your traffic is destined for. It can be an EC2 instance, a container-based application, or any other microservice. And you can also configure it for multiple ports, port 80, port 8080, port 40, anything you want, which is not used by any other application. You can configure your load balancer to target that. And you can have multiple target groups also. So the next one will clarify some of those concepts in a very meaningful way. So you have the load balancer at the top. Yes, it is possible. You need to create a CNAME and then you can configure it. So you have a load balancer at the top and then you are listening for multiple URLs. Say for example, this is the root level that you are looking for, slash, that is www.google.com, that is a slash rule that it is matching, then it is sending the traffic here. So if my URL, the prefix can be anything, that is why a star is here, and then if I have image and then there is a star there, then I will be sending all my image requests here. Any web page will have an image request. For example, Amazon logo or Google logo is required. That kind of information will be sent here. Or if you think of loading a Pinterest page or a Facebook page, lot of photos will be requested for. So the home page will come from this group of servers and your images will be coming from this group of servers. That is how you segregate your traffic and distribute the traffic for better performance of your application. So again, you can have a containerized application completely. You see here it is all ECS it says, whereas these two things are saying EC2, EC2. You can configure containerized applications also and have a rule configured. So this is what we talked about, a load balancer, and it has a listener. That means that it knows what port and protocol it is listening to, and a rule defines what URL it is looking for, and this is a target group. What is the target group that I want to send my traffic to? It can be target group 1 or target group 2 can be called as image loading servers, and target group 3 can be called as containerized services. This is how all the four concepts work together to enable load balancing for your applications. So I don't have anything else to share here. We can go ahead and set up our demo. Let me just quickly check. Yeah, this is a quite interesting thing I wanted to show you how it really works. So think of an application here which is running inside an auto scaling group. You have two EC2 instances and you have a load balancer configured at top of it. So what happens is typically is a load balancer will constantly send information about latency, that is how soon the request is getting sent. Like I'm requesting for a health check and it will say the health check is completed in 1 millisecond. So that is called latency and how much delay it takes for fulfilling a request. That information goes to my CloudWatch group. And also these two servers will be configured to send the utilization. In other words, how much my CPU is being used, how much my network is being used, all that information goes. So CloudWatch will have its own metrics. I would have configured some rules saying if my utilization is going more than 60%, send a notification to auto scaling to execute some policy. So assuming that some utilization has increased, and CloudWatch has sent a notification to an auto-scaling group saying increase my instances. So auto-scaling will automatically add one more instance to my auto-scaling group, and it will also send a notification to my load balancer saying there is a new instance, start sending traffic to the new instance. So automatically your load balancer will attach it to the target group and it will start sending to your traffic to your new instance. This way your latency will again decrease and your utilization on the other two servers will come down. So these are the three services typically you will use in production to ensure that your application is scaling automatically without any user intervention or manual intervention. You need to configure all these services, or you need to be aware of all these three services. We have looked at auto scaling already. We have looked at EC2 already. We have looked at these two, and today we are going to look at how to configure elastic load balancer. This one will be followed on the next classes. I'm going to look at SNS and CloudWatch, that is notification and CloudWatch together. So those two will be easy to understand, and probably after that RDS. Anyway, let us focus on ELB for now. Okay, there are two more things that we need to know before going to the lab, I guess. Where we are in, okay, 3 items before the lab, okay. Healthy host count, that means that let us say you have 40 instances. ELB gives you a metric to identify how many are available at any given time. It constantly keeps a count of how many instances are available in each of those availability zones and gives you a count of them. Because it performs a health check, so it will mark some of them as unavailable or impaired or failed. So you can have a ready-made idea of how many instances are available in your availability zone. Once again, if you have 3 or 4 instances, this number does not matter. But when you're running a web scale application, multiple servers are required, then you will need to know this number, and based on that you will probably take some action. So that is how this number comes into importance. And the next one is latency. We saw how latency is important for triggering an auto-scaling event. As I told you, this is amount of time it requires to fulfill an request. You type www.amazon.com and you wait for probably 1 second to get that request. That is called latency. And if my latency is increasing, probably you won't visit that website and you go to another website. So you need to measure what is your latency and keep it always under the acceptable limits. You need to test it multiple times before identifying your latency metric. Once again, conventional way we do performance testing. Like that in cloud also you need to do performance testing for your application which is behind the load balancer and identify a metric which will work for you. Then there is a rejected connection count. Remember that 30,000, 40,000 example, you have 30,000 requests satisfied at any point of time and 10,000 requests are waiting in the line for new connections. So if you need to keep a count of how many connections are rejected because there is not a healthy instance which can take care of that request. So this way you will know that how many of your users are still not able to reach your application and whether you want to do auto scaling for additional instance or whether you can wait for another 5 minutes so that they can be satisfied. Instead of, think of our example again, instead of 10,000 people waiting, if there are only 500 people waiting, you don't want to start an instance for 500 people. You will probably wait until they have the existing connections are closed out, or you can think that the 500 people can wait for my application for another 10 seconds and they should not have any problems in waiting. Because starting an instance and terminating an instance is going to cost a lot of money. People don't want to scale up and down rapidly. If you're scaling for every 5-10 minutes and scaling down for another 5-10 minutes, you are going to be billed more for that because your instances are charged for per hour basis. So you don't want to scale for 5-minute peak loads. You want to see what is going to be my load for the next 1 hour and scale for that. So that is where your rejected connection count comes into picture. These are all concepts to help you think in an architect mindset and decide when to scale, when not to scale. So this is what we are going to create. We are going to create a classic load balancer. I am going to show you where is an application load balancer is configured and created. I don't have a containerized application code ready for me to develop and deploy there. So we will look at a typical EC2 based application which is running two web servers, and we will load the traffic through the load balancer now. I'm going to create a separate VPC and put two application servers. I'm going to put two web servers into those VPC and create a load balancer in front of them. And for today's demo, I'm going to use the Virginia region. There's no particular reason I'm changing the region, just that I'm doing some testing in Mumbai. I don't want it to be confused with that. So I am already logged into my Virginia region. I am going to go ahead and start my VPCs there. I see a lot of people dropping in and out. Are you people having any issues? Issues. Anybody listening to me? How about you, Madhuri? Vamsi, you're also there? Mr. Srujan, are you having any problems?
Yes, I got a bit problem with the net. That's the reason.
Okay.
Okay, now it's okay. I'm back.
Okay. I finished with my long rambling of what is a load balancer. I'm going to get hands dirty with ELBs. I'm going to start in a custom VPC. As usual, I'm going to quickly set up demo VPC for ELB. I'm going to enable the host names. Let us go ahead and create the subnets. Let us say you can see here, guys, there are 5 availability zones here in Virginia, all the way up to E. I'm going to put only 1A. Let me copy this, it will be helpful. 1A, create. We will create 2 more subnets. 1A, 1B and 1C. I'm going to create all of them. This is not at all required for you guys. I can go ahead and show you directly the ELB setup, but think of it as a refresher on setting up your custom VPC. I'm setting up 3 different subnets now. I'm going to attach an internet gateway next. Okay, we have created it. Let us go ahead and attach it. I'm just going to allow port 80 and port 22 so that I can connect to my instances. Okay, let me edit it, not create a new one. I've selected demo VPC. Okay, edit. In case I have any trouble in any of those instances, I want access as of now. In production, probably you will have a jump server configured and connect to the instances to fix it. Just let me add the routing table and subnets so that internet traffic will be routed outside. Let me just type demo here. As usual, I'm going to create a custom routing table for my VPC. Add the internet route. Then add the subnets also so that all the subnets will have access to the internet. You see all 1, 2, 3, 1A, 1B and 1C. I have just made it easier to remember or recognize. Each of them will give me about 256 IP addresses. Okay, we are set. Our VPC is ready for hosting our web servers now. I'm going to EC2 now. I'm going to give public IP address to only one instance and use elastic IPs for other two instances to download and install the web server. Okay, let us go ahead and launch one instance, first instance. Here is the important part. I'm going to choose the first one on 1A, the first instance. I'm going to assign an public IP so that I can connect to it through the domain name and troubleshoot any problems with it. Okay, this is connected. I'm going to install the web server here. I've just written a quick piece of code so that I don't have to spend time copy pasting it, typing it again. The first line is bin bash. Everybody will know that I'm installing HTTPD. I'm starting it. I'm just echoing a couple of lines so that we will know that we are doing the web server. And I'm also adding the host name so we know that from which server the pages are coming from. So let's go ahead and add storage. I'm not changing this. And tag. Okay, let us call it web node 001 1A availability zone. I'm going to put it into my default security group, which has port 20 and port 80 access. Review and launch. I'm having this key already set up, so let me choose that. So that took about 8 minutes for me. I'm going to go ahead and launch instances. So let it come up. I'm going to launch 2 more instances in availability zones 1B and 1C. Okay, let me just open another dashboard for EC2. Meanwhile, let me launch another instance in 1C also. Let us see. I'm just quickly launching 3 instances, that's what I'm doing. It should be in 1C. So let it launch. I'm just going to go ahead and see what are all launched. I'm going to check whether this guy has come up properly. Okay, you see here, this is the page that we are seeing, and the server web pages from, okay, the text is bad, but anyway, I want you to look and focus only on this part of it. This is coming from 10.181.148. The next one should be 10.81, 2. Something. And you see here it has only an private IP address. So we are going to route traffic to this one. This guy would not have the web server installed because it didn't have access to the internet. It is only a private IP addresses. Although it is in the same subnet, it wouldn't have that. I'll show you how. We need to go to connect to this guy through this guy, and then from 1A we will connect to 1B, and then we will install the web server. Although I configured it, it wouldn't be there. That's what I wanted to show you. Even if you configure it and you enable the internet gateway and don't give it a publicly routable IP address, that instances will not connect to the internet. Sometimes these kind of scenarios will come, so you need to connect to the server through another publicly routable server and connect and fix it. Why is 1C is not coming up? Okay, 1C. And if you see 1C also will have only a private address and it will not be routable at all from the internet. So you can put these private instances also in your load balancer. That is what I wanted to show you. Only one guy here has a publicly routable address, and other 2 of my servers don't have any public addresses. They have only private IPs. So I'm just going to go ahead and install and configure the web server, and then we can go ahead and start doing our load balancer activities. So let me go ahead and open my terminal. I'm going to use elastic IPs. If you remember, I can assign an elastic IP to this guy and connect to this guy directly. Allocate new address. Close. Select this address and say associate address. And I'm going to choose 1A is already ready, so I'm going to choose 1B up. I'm going to say associate. Let me go back to my dashboard. So if I choose 1B now, you can see I have a publicly routable IP address here. And even if I put this in the browser, nothing will happen. This guy should be keep on spinning, and yeah, as you can see, page cannot be displayed. So what I'm going to do is, I'm going to edit this guy, put the public host name, and check whether I'm using the Virginia key. This is the Virginia key. Click on OK, double click this guy. Let me rename this guy to web node 02. Okay, I'm connected now. Let me jump to root. Just to confirm, there is no status HTTPD. As of now, HTTPD is not even installed. So I'm just going to copy paste my code from here. We have an opportunity to correct this. Web pages. So from, okay, that should do. I'm just installing my web server now. Okay, if we go ahead and refresh this page, I should be able to see here, this is 10.81.2 something, blah, blah, blah. If I go to the previous one, it is 1 dot blah, blah, blah. So I'm going to remove this public IP address and assign it to the third one, third instance, that is 1C instance. As of now, see 1C is having only a private IP. I'm going to associate a public IP, that is elastic IP, and install the load balancer, install the web server there. It's very quickly done like this. You go here, dissociate address. I'm going to associate it with 1C now. Just going to choose 1C. And voila. If I go back to my console, oh yeah, where is my EC2 console? Instances. Now if I go to my 2 now, you will see it has come back to my private IP address. So the web server is running and it is accessible locally through this IP address now. But if I refresh this page, this will be gone. I'm going to do it in another page now. It is now pointing to the third instance, so I don't have a web server running and there's an error message there. So let us go ahead and check this guy. This is fine. And if I go to my PuTTY terminal, this guy should not work. See, it is closed off. Okay, let me connect again. Come on. Since the IP address is the same and the key is also same, I should be able to connect directly. Did we associate successfully? Okay, it is taking a while. Okay, wait. Let me go to root. Okay, nothing is running. I'm just going to copy this code and paste it again. Okay, that is working. I'm just going to refresh this one. See here now, this guy is from 10.181.3 now. So first guy is 1, second guy is 2, and third guy is 3. So we have 3 servers giving web pages, and the content of the web pages will be different from where they are serving from. Okay, I'm just going to remove my public IP from this guy also. I'm going to dissociate address. So this is where I go to configure my load balancer. Under EC2 on the left hand side you will see load balancing and you have load balancers here. I'm going to click on this option now. This is actually where the demo starts, you can think of it. So far we have set a custom VPC, we have set up 3 web servers and you want to load balance those 3 web servers, that is distribute traffic among these 3 web servers equally. So what you do is you come here, you come to this dashboard and click on this big blue button which says create load balancer. And remember, I told you application load balancers are here, and in classic load balancer we are going to use the classic load balancer, which is mainly for TCP, HTTP and HTTPS traffic. They are pushing everybody to this one because This one gives you much more fine-grained access. Remember the slash images and containerized application I talked about? Those all happens here. We are going to see it in a very simpler way right now. We are going to go ahead and click on choose this option and click on continue. When you are starting with load balancers, start with classic load balancer. Once you understand what is your application, how you can redirect a load within your application, then you can go ahead and configure application load balancers. This name is custom defined, so I'm going to give demo ELB, and I'm going to choose the VPCs that we chose specifically for this purpose. And remember, I talked about this create internal load balancer. What this means is this load balancer will not have an internet facing access. It will be only for within the VPC traffic. We need it internet facing, so leave this option unchecked. And I'm going to, this is my listeners. Remember, listeners are nothing but protocols and ports. So I'm going to say I want HTTP protocol and I want my load balancer to listen to port 80. And this is on the front end. What is the back end port I want to send the traffic to? I can run my web server on 80. On the front end, I can listen for something like 8080 also. So you can have different combinations also possible here. Because sometimes people don't want to run applications on the default port to avoid hacking traffic or intrusive attempts. So the front end, the world facing port will be something different. So in that case, you will put that number here and send all traffic here. So then, as usual, it is asking me what are the subnets I want to choose. It says select the subnets and it gives me for that particular VPC, that is this VPC, I have 3 subnets available. So I'm going to choose all of them. Click on this big button here and it says selected subnets, all 3 of them. So next is to configure the security groups. So the security for my load balancer is defined in 2 layers, that is putting them into a VPC and configuring my security group with particular levels of access. So I'm going to use my default security group. In production, again, you will configure a separate security group, but it doesn't matter anyway, because it all matters is what incoming traffic you are allowing and what IPs you are allowing. For our case, we are creating an external world-facing load balancer. So in that case, I am going to put it in the same default security group. And it says that your load balancer is not using a secure listener. That means I have not configured any HTTPS or SSL traffic. So it is giving me a warning saying, do you want to continue? I'm going to say yes. My demo setup needs to be configured with HTTP only. Now I want to configure my health checks. So if you remember, we have done listeners, we have done target, next is the target. We are doing health checks now. Next is the target groups. So what is a health check I want to do? I want to do HTTP health check and I want to do it on this port, and this is the path I want my server to ping upon. If you remember, I created a file here in each of your servers. Say for example, index.html here I have created. So my load balancer will request for this web page on this port using this protocol and see whether I am getting a response. So if I am not getting a response in 5 seconds, it will retry after 30 seconds, and if it will try it 2 times, and if it is not getting a response in about a minute, it will say that that instance has failed, the health check has failed. That is what the setting is. It will time out in 5 seconds and it will keep on trying every 30 seconds. And if it is failing for continuously 2 times, and it will say that health check has failed and it will mark it as unhealthy. So next is my target group, attach EC2 instances. I am going to go ahead and attach my EC2 instances now. So I have 3 running, web node 1, 2 and 3. I am going to select all of them, and it is, see here I talked about cross-zone load balancing because we have multiple subnets and all of them in the same AZ. If you notice, I have not used different, I'm sorry, all of them in different AZs. I'm absolutely sorry about that. So we need to enable cross-zone load balancing so the traffic is distributed between AZ1A, AZ1B and AZ1C also. And what is this connection draining? Remember the connection timeout, it will wait for 300 seconds and if there is no activity, it will stop sending traffic to that instance anymore. Slowly, it will try to retrieve the traffic from that instance and send it to another instance. So 300 seconds is the time it will wait before it will drain the server of any connections and mark it as unhealthy. So the description also says the same thing, the number of seconds to allow existing traffic to continue flowing. So next is adding tags. As usual, you can give it any user-friendly name that you can remember easily. Demo, let me give once more, case demo ELB. I'm going to review and create. It gives you all the parameters that you chose just now, and it allows you to review everything and click on create. That's it, more or less. We are done here. Let us wait for the load balancer to complete initialization. The request has been accepted. Whenever you see this message, that means the request has been accepted. It may take a few minutes for your instances become active in the new load balancer. What it means is it is creating the load balancer and doing all the internal configurations. You see the state field here. This state field will become available, I think. If I remember correctly, I think it will become available or provision. I forgot, but that we will see some text there when it is ready. And this is the DNS name for my load balancer. So we can copy paste it and keep it ready. We can put it in the browser window and wait for, copy. As of now, there should not be any page delivered because it is still getting provisioned. Let us meanwhile go and look at all these fields. The description is the basic configuration what we have done so far. It just gives you all the attributes. If you want to create access logs, it will ask you to give you an S3 bucket and it will dump everything at the intervals that you choose. Like all you have to do is choose this 5 minutes, and if I have the URL for my bucket, I can give it here. URL or ARN, whatever you like, you can give it here. So as of now, I don't have any buckets configured, and as you can see, cross-zone load balancing is enabled. If you want to change that anytime, you can go ahead and change it. It is, as I told you, click of a button, and enabling this, make sure your instances are balanced. So let us go to instances. So you can see all of them are already in service. That means that if I refresh this page, something should be visible right now. No, not yet. It is still getting provisioned. Okay, when you get an in-service notification, that means that the load balancer is able to request web pages from each of these instances, and it is getting a successful, healthy response. That is what it means. And you can see below here, healthy, it says yes, yes, yes. If for any reason, if the load balancer is not able to reach any of the instances, you will find this column to be no here, and this is where you will troubleshoot it and find out why your instance is not working properly. So that is what this page is. If you want to edit, for example, if you want to add additional instances here, you will go ahead and do it in this page. If you want to remove also, you do it from this page. But if you have an auto-scaling group, we will do that automatically. Probably in next class or after that, I will show you how to do auto-scaling and register it in a load balancer. For now, let us focus only on the manual way of doing things. Auto registration and the re-registration will be happening through auto scaling, and we will do that in another demo. Health checks, we already saw that. The listeners, the default one, if you want to add additional listener, you can go ahead and create it. Monitoring is a very nice way to look at your instances. I might see a dot or something when my instances are coming up online. Usually unhealthy instances means 0 means you will find a dot here, and healthy host is 2 means you'll see 1 here and 2 somewhere up above. It should be ready anytime now. It takes about not more than 1 or 2 minutes. Let us just wait for some time until it gets ready. So that is all for load balancers. I'm just going to wait for some time until the load balancer comes online. So far, are we good? Everybody, who are all there? I'm not able to keep a track of who is there. Okay, I see everybody is still logged in. So far, are we good, people? Okay, my load balancer is still not coming up online. Okay, at least an S no is not coming today. I wanted to show something also. Remember, we created some flow logs. If you don't want to get confused, I can quickly go and show you the flow logs. The whatever we did yesterday, the logs were created. While it is getting loading, I just want to use the time effectively. It is in CloudWatch. Okay, let me go ahead and refresh it meanwhile. No, it's not happening. Surprising, isn't it? On Origin servers, still I'm not able to get my load balancer up and running. Okay. Yes, Anil, I will need to create an SSL certificate for that, for HTTPS to work. Without an SSL certificate, I need to go to certification manager and create it. Probably not now. I can spend some time later. So, guys, I'm not sure. Let me zoom here. Oh, too much. You can see here, I zoomed in a little bit. Okay, let me readjust this one a little bit more. F11 will help. No, not much difference it makes. Okay, what I'm trying to show is the unhealthy host. You see here the small blue color line starts appearing at the bottom. That means that my load balancer has started working and it is able to health check continuously. And for healthy host, it's started showing a blue line here at point number 3. That is, I have 3 hosts and all of them are healthy. I just clicked on the chart and it is started opening another bigger window. I can now zoom to default size. So you can see last 3 minutes or so, something like that, because it polls every 30 seconds and the period is 1 minute. So last 2 minutes it has polled and it says that I have continuously having a healthy host of 3 now. So unhealthy host, if I click on that, I should see at the bottom 3 lines. We can go ahead and refresh our web page now, it should work. So this is how a quick view we can monitor it. Let me go ahead and refresh my. Strange, guys, really strange. Why my DNS name is not working? Wait a second. Everything seems to be fine. I am stumped. I'm just thinking what could have gone wrong, because I'm able to get healthy host count. Okay, what I'm going to do is I'm just going to listeners. Okay, health checks, index.html, port 80, everything is fine. 80 and 80. It should be fine. Just thinking what could have gone wrong. This is, I'm just going to connect to my one instance which has public routable IP and see if there is anything wrong, if the server is still running. Where's my instances? In theory, it should have worked and I should be able to get a web page here. I'm actually on.
Can we try to access instance wise? We can come to know, right?
Yeah, that is what I tried. I don't want to show that. Only the first instance, the second and third one don't have a public IP, so it should not work.
Yes.
The first one I'm going to copy paste in the browser. Okay, that guy is nicely working as of now. I am thinking, did I make any mistake in the load balancer itself? I'm going to change the listener to slash now. Let's see what happens. It should not cause any problem at all. I should get at least a response from this guy, that is 1A guy, because he is already having a publicly routable IP and my load balancer should pick it up automatically. Let me refresh this page. Everything is working fine. Let me just copy this guy again. No, strange it is. Okay, what is that IP address of that guy? And I'm going to remove these two guys. Have only one of the public instances. I'm going to have only this public instance and see what happens. My apologies guys, I think I messed up something. I'm just trying to troubleshoot right in front of you. Very bad of me, but anyway, that is how things happen sometimes. I'm going to go to my monitoring and see if it is reflecting after some time. You should see this bar, this one coming from 3 to 1. That means that my load balancer has picked up the changes. "30 seconds, I need to wait." Meanwhile, let me connect to this guy. This ping not in group, what I did not get that message again. Okay. Oh, great, awesome. No from this guy. Okay, definitely something wrong with my load balancer. Okay, we are good here. Just going to see if this guy is going to reach this guy. Okay, of course, Amazon has disabled paying for load balancers. Okay, why it is not picking up the changes also? Now, okay, it has picked up the changes. Okay, I'm out of bounds right now. I have no clue other than recreating this one. Okay, let me just go ahead and look into each one of them. Yeah, true. Let me go ahead and review each one of them. Internet facing. One instance. I'm just going to check whether I have port 80 access configured here. Just blind luck. Did I disable this port? Okay guys, officially I give up for the moment. I will show this demo again. I'm not sure what is the problem. I'm not able to quickly find out. Time is running out. I will show this demo tomorrow. I mean tomorrow is Saturday, right? Monday then. I'll show this demo on Monday as well and see why it is not working. I have no clue as of now. I'm just trying to go over each of those details. Okay, this is all fine. Instances. Okay, in this setting I can't find anything wrong. Health check is also fine. What gives? I'm going to create another one. I'm going to delete this guy. What happened? we have created listeners, we have added subnets. Okay, we are good here. Okay, this is the last throw of my dice, otherwise I'll have to troubleshoot it separately. Okay, question for all of you. At least the theory part is clear, so I can show the demo on Monday. I'm going to wait for this second load balancer to come online. If it is working fine, we are all good. If it is not, I will have to show it on Monday again. So I'm asking you guys, you want me to repeat anything in the theory part or only the demo part? Silence. 1, 2, 3, 4, 5, 6, 7, 8. It is still not coming online. Okay. I don't have any hopes of this one also working either. But let us see. Awesome. I don't understand why the previous one wouldn't work, but this one just works out of the box. I'm going to add the other two servers also. Edit instances. I'm going to put this URL in the chat window. So I'm going to ask everybody to check it. If you keep refreshing, or if you try to request multiple pages, you might see this number change from 1 to 2 or 2 to 3, depending upon the load we are all creating. But of course, that is after it has come into service. Let us see how long it will take to come into service. Monitoring. Okay, it's still not started showing it. It takes about 1 or 2 minutes to. Oh, really? I'm sorry. Past 1 minute. Okay, let me just click on this one. Okay, this is what unhealthy host is 0. Okay, great. Healthy host. Let us go ahead and see how many have come up online. Okay, from 1 it has become to 2, 1.8. Okay, I'm just going to hit on refresh. Refresh. Okay, it has come from 3 now. Refresh again. Again, it has come from 2 now. Okay, finally, it works. Okay, to be honest with you guys, I seriously have no clue why the previous one did not work. I'm not even sure why it didn't work. But sometimes in Amazon, this is what they call pet versus herd theory. Don't get hung up on something that is not working. Sometimes it works very effectively by throwing it away and setting it up again fresh, because every configuration is dynamic in the cloud. You don't have to get tied down to one particular instance and try to fix that one instance only to get it working sometimes. If you are having only one database server, one web server, like in traditional environment, yes, you need to spend time to fix it. Then we call it as a pet, like a dog or something. You want to take care of it. You want to make sure that it's working and healthy. But in cloud, it is every instance is same as every other instance. So if something is not working, you just throw it, discard it, and treat it as a herd. That is, lot of sheep is there. One sheep is dead. You just don't worry about it. You just take care of the rest of the sheep and move forward. So that is what I also did. I tried to fix it. I couldn't find out where exactly the problem is. So I threw away the not working load balancer and created another load balancer. Absolutely same configurations as you might have seen, and it works out of the box. So what I'm trying to say is, always remember that you don't have to get hung up on one instance that is not working. Go ahead and fix it by starting another instance if that would help. So I can see it perfectly working now, because I can see the IP address constantly changing from 1 to 2 to, I mean, it is round robin. Like now it is 3, it will go to 1 most probably, and then 3 now, 2 again. Yeah, it's doing a round robin perfectly now. That means that the traffic is load balanced among the 3 instances quite uniformly now. So that's all it. We have already spent about 1.5 hours trying to get it understanding and get it working. Any questions?
Naveen, are you here?